Hello, my name is Nicholas and welcome to another Swarm update video. Since the last update, I've mainly been working on improving the visual aspects of the simulation, making it a bit clearer for people to understand what's going on and also giving you the ability to have a look at what particular robots are doing. I've improved how some of the robots work internally just to improve efficiency, and I've also updated the controls to make things a bit easier to create and move around. So, let's have a look at the simulation. First thing I'll talk about is the visual improvements. Right away you should notice that the robots are now a bit easier to identify. I've removed a lot of the color flashing around the outside of the robots because that was confusing people. Now the movement robots are red and stay red, the scout robots are blue and stay blue, and the task robots are yellow and stay yellow unless they're flashing while digging. And this removes a lot of the visual noise and helps robots to have a consistent visual appearance and be easily identified. What I've also done is changed the mouse, no longer have a cursor, replaced it with a little grey dot, just to sort of make that look a bit nicer. And I've also included a debug status readout at the top corner. This can be turned on and off, and it will show us the amount of time the simulation's been running. It'll show us whether or not the simulation's paused. It will show us things like whether or not we're spawning tasks. This is a new feature I've added, allowing the simulation to, on a countdown timer, spawn new tasks within the world. So it will spawn rocks, and it will also spawn these new flags, which I'll talk about in a second. It'll spawn up to 25 of those, and when it reaches that maximum limit, it will start removing ones that have been hanging around for a long time, simply so that the screen doesn't get cluttered with tasks that are outside of the network's reach. This debug also allows us to see information about objects, so we can click on an object and it'll tell us some information about what it is, where it is, and we can click on our robots and see what our robots are doing. We can see where they are and any tasks that they currently have, along with the type of task and the destination for that task. So we can not only see what our movement robots are doing, what our task robots are doing, but we can also see inside of our ScoutBots the number of requests that they have and what those requests are. There is also the ability for this status readout to be attached to follow whatever robot you have currently got selected, or whatever object for that matter, simply so that if it's really busy and you're not entirely sure what robot you're looking at, you can just attach that to the robot and find out. Some of the mechanical changes I've made: Scout robots now have a limit to the number of requests that they can hold. They can hold up to 20 requests, and once those 20 requests are reached, it will then remove requests based on how far away those requests are from the current Scout robot. So it will prioritize storage of its own tasks over storage of other robots' tasks. And it also means that any tasks which are nearby are likely to get fulfilled first, which will stop them from getting spread too far throughout the network. What this also does is it removes a lot of the lag that was created by tasks getting passed backwards and forwards very frequently. By limiting it to 20, we're not going to have hundreds and hundreds of requests being copied backwards and forwards from each Scout robot every frame. So that's a big improvement on the efficiency of the simulation, causing it not to lag out. Another change I've made is the inclusion of these flags. These flags are task spots. What these task spots do is that they are physical representations within the world of certain tasks that need done. These red ones that you can see all over the place, these are dig type tasks. So any Scout robot that can see these flags will see these particular flags and say, oh, something needs to be dug there, or a dig type request needs to be created for that location. And that is then able to capture those requests and spread those requests throughout the network. What this means is that now our dig robots, these dig robots are now no longer randomly creating a task within the world and then going towards it. They're actually being summoned to these dig spots specifically. Another mechanical change which I've included is the ability for the shuttle to start spawning random types of robots depending on the number of rocks that have been collected. At the moment it's disabled, but when I enable it, every 5 rocks that the shuttle processes, it will spawn a random robot. It can be a task robot, move bot, scout bot. It will spawn a random robot, and that robot will then move out into the network. And this was very much to test whether the network could expand and whether the network could deal with expansion all on its own, rather than being told how to handle the inclusion of new members into its network. Now moving on to the improvements I've made to the controls. We still have our standard visual range and connectivity indicators. The connectivity indicators now work with the taskbots, just so you know. But what I've also done is I've included obviously the ability to pause the simulation, the ability to step the simulation forward frame by frame, the ability to not only spawn scout robots but actually spawn movement robots and task robots now. And I've also added the ability to spawn rocks as well. This means that the user now has the ability to actually poke the network to give it different scenarios and circumstances and see how it reacts. For example, we've got a disconnected network at the moment, so we can add more scout robots. We can add long chains of these scout robots. We can see what happens when we create a whole bunch of rocks in a far out part of the network. We can see what happens when we spawn movement robots in various locations. Whether we get movement robots and task robots that are separated, how they behave, and that sort of thing. That's about it for this update. What I'll be working on in future is getting solar robots implemented, so giving robots an internal battery that drains down and needs to be recharged, getting solar robots to find solar recharge spots, be taken to those spots, charge up, and then come back to the main station. In a similar way to how the taskbots already work, and then have the shuttle have an internal battery storage and then be able to recharge other robots nearby using that battery storage, also including the ability for the robots to identify when they are low on power and when they need to return to base to recharge. Hope you guys enjoyed this video. If you're curious about how I've made this or suggestions or anything like that, leave them in the comments section below. Give the video a like if you enjoyed it, and subscribe if you want to keep up to date with my future updates. I'll see you guys next time.